Okay, we have so many nice
So,
people here.
wow.
So hi everyone. Okay, so as we wait for the rest of the people to join us, let me welcome everyone to these. This is the third talk this year in corpus linguistics and applied linguistics research. This is the 2025 edition, and as you probably know, we've been doing this since 2021. So we've always had fantastic speakers, and this year lineup is unbelievable. So we are so glad to have such a, fab lineup. Um, we have the talks on our YouTube channel in case you are interested in some of the talks in the past. This edition is sponsored by the Faculty of Arts and Humanities of the University of Murcia, the English Department, University of Murcia, and the Education University of Hong Kong for the first time. So hopefully this will be a new tradition that we have in this series. This particular edition, 2025, is devoted to thinking about the impact of AI on corpus linguistics. And yeah, this is the research group YouTube channel that I mentioned earlier, 2021 edition, 2022, 2023, 2024, and 2025. So we've already had Lisa Chen and Peter Crosswaite that opened this series this year, Angel Ma 2 weeks ago, if I remember well. And on Thursday, we will have Professor Atsushi Mitsumoto. Um, today, this is on Thursday. Today, we are lucky to have Professor Laurence Anthony with us, and Professor Angel Ma will present and introduce Laurence Anthony and will chair this session today. So thank you, everyone, for joining us.
Okay, thank you, Pascual, for introducing this wonderful, Corpus, series online, seminars, which have benefited, I think, people all over the world, right? In the past, since 2021, right? So in the past almost 5 years, right? Okay, yeah, good. So today we have very pleased to have invited Professor Lawrence Anthony, and in the past, we also invited, Laurence to provide his online seminars for us. So I can tell you, you will enjoy his, seminar. He's a very engaging, speaker. Okay, all right.
I'll
So,
try.
Professor Lawrence Anthony is a professor of applied linguistics in the Faculty of Science Engineering at Waseda University, Japan. He holds a Bachelor of Science, in mathematics, physics, okay, from University of Manchester, and also he held, a PhD in applied linguistics from University of Birmingham. So I think he's the ideal person, is combine, AI technology, with the language learning, So he's a founding member of the Center for English Language Education in Science and Engineering at Waseda University, which offers discipline-specific science communication courses to over 10,000 students. His primary research interests include language data science, AI, corpus linguistics, educational technology, and English for specific purposes, program design and pedagogy. He's best known for his work on corpus software tools, including the development of Nkong, which he studied more than 20 years ago, and he kept and he keeps updating Nkong. And I think today he's going to introduce a new Nkong to you, with AI integration. And the development of Nkong actually earned him the national prize of the Japan Association for English Corpus Studies. Okay, so let's welcome, Lawrence. I pass the time, to Lawrence. Okay.
Thank you. Thank you very much. Just a minute. Let me get my screen showing. So you should be able to see that. Is everybody okay? Can you all see that? Great. And let me also make sure I can see the chat in there. I can see lots of very nice comments there already. But first of all, thank you so much for inviting me, Angel. It was it's an honor to be able to present this part of this series, especially with so many other great speakers coming before and after me. And also thank you everybody for coming. I can see hundreds of people in the session today. So that's so amazing to see so many people interested in generative AI and its integration with corpus linguistics. Okay, so as you can see here, I've got this kind of rather strange title called the Symbiosis. Oh, just a moment. Wait just a minute. Okay, that's better. Okay, a symbiosis of generative AI and corpus linguistics. So what's that all about? So if you've been following the trends in generative AI and corpus linguistics over the last couple of years, people are certainly getting more and more interested in these two approaches. And often it's looking at how they can be combined or integrated together. So I wanted to look at that today and see what this symbiosis or this integration might look like. Over the last 2 years, though, I've also noticed an increasing kind of worry or kind of threat, a perceived threat about generative AI. And is it taking over corpus linguistics? Is it going to kill corpus linguistics? Is it going to replace corpus linguistics? Is it the new corpus linguistics? So when we think about this symbiosis of generative AI and corpus linguistics, we might kind of think of something like this: a dangerous takeover. This is the Venom movie where we have this parasite basically taking over this human and doing crazy things. Is that what this symbiosis looks like? Or is it something more like this, where it really is more of a productive partnership where we can work together with AI and do more interesting and valuable things? I hope today to kind of pitch the idea that it's a productive partnership that we can have, especially if we understand what AI is and how it works and how it basically really nicely integrates with what we've already been doing. So that's basically the theme of today. I should say that this is largely based on a paper that is just being published. If you look at the date here, you can see it was published on November 21st, so 4 days ago. I have a paper in Professor Barr and Professor Crosswaite's special issue of the Cole Journal on corpus-based pedagogy in the AI era. And this is looking at this tool that I've created, which is part of ANCONC, which I'm going to be introducing today. But I've got the chance now to pitch a couple of push a couple of other papers that I've got coming out. So also, I've just got this paper published literally like yesterday. I think this came out like a day ago. And this is not really directly related to what we're doing today, but it is about concordancing with AI. So you might be interested in looking at that. That's all open access as well. So if you're interested in having a look at that. And also coming out very, very soon is another paper I've got called AI-Assisted ESP Course Design and Implementation. So this is not specifically about corpus linguistics, but it's still about AI and how we can incorporate that in our more regular teaching, especially in an ESP context. So if you've got any chance in the next couple of weeks, maybe have a look at those papers because they're all kind of related. Okay, so I'm going to start off by introducing large language models. I want to explain what they are in a way that everybody can understand so that we don't fear them, like that venom parasite. If we don't understand something, it's really easy to start worrying about what it is and what it can do and how it can take over. But if we understand a little bit more about what it is, maybe we can then utilize it to our advantage. So I want to talk about what large language models are, especially in the news, and then the architecture that's being used, and then what are their strengths and challenges and limitations, and how does that relate to corpus linguistics? And then I'm going to talk about this integration of corpus tools with AI using this Chat AI Corpus AI platform. I call it an experimentation platform because I'm not suggesting that this is how all corpus linguistics should be done. It's more of a platform that allows you to play with AI and see how it might integrate with corpus methods. And it's really that interaction that we can experiment with, trial, test, see what works, see what doesn't work. And as a result of that, have a better understanding of both fields and maybe move both fields forward, and which will be my summary at the end as well. Okay, so let's start with what is a large language model. Well, we've all heard about all these big companies that are pushing large language models, OpenAI being probably the leader in the field, but then Microsoft and Google and Meta all coming up. Huge companies pushing this idea that AI is taking over the world and it's going to introduce this new amazing world for us all to act in. And a lot of other companies too have got on board of this AI hype, perhaps, or certainly this trend. And the idea is that AI is good. That's what they're trying to pitch. Okay, now we can discuss that. But if you look at the impact already, even just after a couple of months of release, ChatGPT reached 100 million users. So certainly people seem to find it useful for certain things. I would imagine everybody in the room today has used some kind of AI system for something that they found useful. So there's a big push here. And if you look at OpenAI's ChatGPT tool, which has been released just a couple of years ago, 3 years ago now, this basically a friendly assistant. Hi there, how can I help you? And it's designed to assist us and help us and allow us to do new things and traditional things in a better or faster or more efficient way. So this kind of looks good, but when you look then at what actually happened in the world, we kind of start seeing some of the potential problems. So ChatGPT, this was a news report from 2 years ago. ChatGPT passes exams for law and business schools. Sounds amazing. Wow, they're really smart. And then just a couple of days ago, we hear a leading law firm in London cuts back office staff as it embraces AI. So AI is great, and then people lose their jobs over this. So is that the future that we really want to see? If you look in education, again, these AI tools are getting better and better, but it leads to problems with students using them to write their essays. We've got plagiarism problems, and all these other issues start coming out. And I think this is where we're kind of at right now. I feel that we started off with this hype of AI being this really great thing, really smart, really useful, and then people started getting a bit worried about it, and we're on this downward trend now. It's like AI is maybe evil and horrible, and we shouldn't be using it. And just as an example of that, again, just a couple of days ago, I read this report about a book prize where the authors who were going to be nominated for this book prize were removed from the nominations because the cover of their books had an AI design on it, an AI generated image on the book cover. So this is nothing about the content of the writing, nothing at all. It's just the publisher used an AI generated image, and that led to them being not nominated for this book prize. This is this maybe an overreaction to the lack of understanding or the uses of AI? Are we heading the same way with our field, where we might have a case where if you use AI for doing your corpus research, you cannot get published? I could imagine that being a world that we're running into if we don't understand it and we don't embrace it in the right kind of way. So so this actually comes to the final part of this opening, where we have this famous quote from Ian Malcolm. I'm sure you know him. He's a doctor of mathematics, and he's a fictional character in the Jurassic Park movie. And he said, "Your scientists were so preoccupied with whether they could basically create dinosaurs that they didn't stop to think if they should create dinosaurs." And of course, in the movie, the dinosaurs run amok and start eating people. So where are we with AI? Are we in this world where AI is good? Or are we in this world where we should be banning it or not using it, worrying about it, and so on? My position is that, like many tools, they can be used for good and for bad. And the better we understand the tools, the better we know their limitations, the better we know their challenges, and the better we can use them effectively. So it's almost the same argument as guns and nuclear energy and other things like that. So let's try and understand what these are, and hopefully that will lead to a better future for us all. So a future where we have a good partnership, not some kind of dangerous symbiosis. So large language models, here's a nice definition, are usually transformer-based neural networks. They're a neural network designed to represent language, process language, and generate natural language. That's it. Okay, they're part of a broader family of AI models, including generative AI and discriminative AI models. So a large language model is not generative AI. It's just almost an application of the model. And we can also apply these models for classification tasks, which would be under discriminative AI. So we have to be careful about this umbrella of generative AIs. The language models themselves are not generative AI. They're just a model that represents, processes, and generates natural language. So you have to be a bit careful about that. So these models came out many, many years ago, probably about 50 years ago, even earlier than that. Well, certainly these neuron models came out a long, long time ago. Okay, so these models are basically attempting to replicate what we have in our own brains. And in our own brains, we have, of course, neurons, and as you can see here, we have a nucleus, and then we have these dendrites coming off from them. And we have an electrical impulse goes into the neuron, and then it processes it in some way, and then sends out a signal to the next neuron or the next set of neurons. And that integration and that network of neurons firing allows us to move our arms, our legs. It allows us to think. Although there's some magical property in the brain that we still don't fully understand, that this is the model that our brain uses. And the idea was to replicate that in a mathematical model. And this is what we have. So this is basically the start of a large language model. It's a single neuron, but we call it a perceptron in the field. So you can see here, we still have the some axons coming in. We have some, so these could be considered like the electrical pulses coming in. We have this little neuron, and then we have an output. Now, it kind of looks a bit complicated here, but the idea is that if we have these simple neurons and we combine them in interesting ways, we can replicate the kind of processing that happens in the brain. And then if we have the right inputs, and we have the right learning algorithm, it can mimic what humans can do. And we're kind of seeing that in these models' ability to generate language, understand photographs, generate music, and so on. Now, this is a very simple construction, a very simple network with just 3, 7, 9 neurons in it. But of course, we can expand it to have more neurons, and then it gets more and more complicated. And this is where we have this idea of a black box. What is happening, or what are all these neurons doing? But if we just go back and look at this model here, we actually see at the very basic level, we just have this. A weight times an input plus some kind of offset, some kind of scaling factor equals an output. W multiplied by X plus B equals output. And we might have recognized this. If you've ever done linear regression in the past, you know that we can work out the height of somebody from a weight times the age plus some factor, and we get a height. It's a straight line, basically, straight line graph. And we can work out what the W and the B is to get the straight line. So a neuron, as I'm just saying here, or a perceptron here, is simply linear regression. That's it. What's interesting, though, is when you start combining these neurons into different patterns, we're able to go beyond just a straight line prediction, and we can start modeling all kinds of shapes, and that leads to interesting patterns, interesting formulations. So let's look at that briefly, and this will be brief, but I hope this might be interesting for some of you. Okay, just a moment. I'm going to share a different screen for a moment. Okay, let's see if you can all see that. Can you see my perceptron screen? Yep, great. Okay, so here we have that one neuron, or perceptron, I should say, perceptron. Now we have an input and we have an output, and we have a straight line. And we can move this weight to make the angle higher or lower. This is standard regression, just basic regression. We can move the line up and down, and by changing these weights and these biases, we can end up modeling points on the line. So like a height based on the weight, okay? Which is great, that's it. That's what a neuron does, a perceptron does in these language models. So is that it? Well, we can start adding a few more little functions to make it more interesting. Now, language isn't linear, right? We don't learn in a linear way. Frequencies don't operate in a linear way. So why are we using linear regression for so much of our work? Language models don't use linear regression because we can add what's called an activation function at the end after that little function. And the activation function, like ReLU, just puts a kink in the line. So I can move this around now. And can you see that little kink? We have a little kink there. So when we go down, it suddenly becomes 0. And this could be, for example, heights. When you're born, you already have a set height. And then as you get older, you start off with the same height. And then as you get older, your height increases. So we need a model like this to model height. And of course, linear regression cannot do this. But suddenly we have this network that can model something like this. So it's a non-linear model, which is very cool for even heights, but you can imagine language is even more complicated. So let's add an extra neuron, and now we have 2 lines now that we can model. So we can change the angles of one, and we can change these patterns of the other, and then we can see what the value would be at different times. But these 2 lines are completely independent of each other at the moment. What would be really good is to start thinking about a classification kind of approach where if this is likely, if the purple line is likely, then the red line is unlikely. So it's a probability distribution. So we can do that very easily by, instead of just having these 2, we link them together with something called a softmax equation. Basically, we take those 2 outputs and we put them into a probability of 0 to 1. So now when we move this X and Y, you can see if the purple is probable, the red is not probable. And now we have what is more likely. Is the purple more likely or the red more likely? But look at the non-linearity of the graphs that we can make with this. Very simple neural network, very simple. But now we can model all kinds of weird shapes like this. We can make this bigger or smaller. We can make this wider and so on. The final part of the equation is that really makes this special is that we also connect these 2 neurons directly together like we have in the real brain. So we have what's called a hidden layer. Those bits are hidden in the middle, and we connect the outputs across. We cross the outputs, and then we have the softmax after that. Now, what does that do? I mean, it kind of looks a bit weird here, but if we combine these 2, then we get something that looks like this. We have a lot more parameters now, but when we start modeling things, we can do things like this. We can do really crazy different curves and shapes, and we can then model all kinds of values. Look at this. So red line, at this point, this is probable, the purple is not probable. As we go further along, suddenly they're both the same probability, then it reverses, and then it kind of kinks and goes all weird like this. So we can change these weights to model all kinds of shapes and so on. Look at this. This is another just different shape. So what the point of this is that these very simple networks are able to model very complicated relationships. Now, we're only looking here at one value at the moment. How does that one value change depending on the situation? But it's a very complicated relationship that we're modeling even here. As we make the model bigger and bigger, we can model more complicated functions, and ultimately we can learn to model something like language or image processing and so on. But it all comes down to linear regression at the very basic level. So we don't have to be scared of AI, because in some way it's just boring mathematics. Okay, so let me go back and share my slides again, my main slides, just a moment. Okay. Does that make sense? I can see Pascual there looking at it. Just kind of, do you get where it's kind of going? You're smiling. Maybe we can ask this in the Q&A later. Okay, can you see my slides again? Is that okay? Yeah, great. Okay, so basically we have these neurons doing linear regression, but then we add these activations to make it non-linear, and then we cross these the connections to introduce more complexity and make it more interesting. Now, when we go further, then we can start then combining these in very interesting ways, these neurons or these perceptrons in all kinds of different ways. And one of these connect models was called the transformer model, and this was proposed in 2017. I won't go into the details of this model, but it allowed people to predict a good translation of one language to another. Modern models that you see in ChatGPT and so on are actually simpler than that transformer model of 2017. And this is the standard architecture now for the Llama 3.2 model. Again, I won't go into the details of these different points or blocks in this model, but ultimately we're just doing what I just showed you a few seconds ago. It's combining these little units in interesting ways, connecting the outputs in ways that allows us to model complicated relationships. So once we have this model, now we understand it a little bit maybe, we can start predicting the next word based on this model. What would be the most probable next word that comes out of this from the inputs? What's the most probable output? And then what magically happens is we can start training these models to act like information retrieval systems. So we can input a question like, what is the most famous place in Japan? And the next word becomes the answer to that question. We can say, write a one-sentence definition of corpus linguistics, and the output becomes the definition of corpus linguistics. Again, we can do the translate the definition into Japanese, and we get the translation, and so on. So just as an example, you may have seen this before. What is the most famous place in Japan? The next most probable word is the, and then most, and then famous, and then place, and we get this beautiful answer to this question. One sentence definition of corpus linguistics, we get a nice definition of corpus linguistics. Remember, though, this is from this model predicting the next word. That's all. Okay. We can also do translation. So how does it translate? It's no different from writing a definition. It's just predicting the next word. And because these keywords like definition and Japanese were coming in the input, the most probable next word would be a Japanese word, and we have a Japanese definition coming out. So it's kind of strange and magical in many ways. Can you help me? Again, exactly the same process, but because we have that can and the help and the question mark, the AI model knows to predict the next word as being of, course, and so on. And we can get what looks like a chatbot. Somebody's talking to us, even though it's just predicting the next word. It's just mathematics in the end. And we can also use it to write code and stuff as well. So here's a code that it can generate. And remember, the code is just more tokens being predicted by the model coming out. It's no different from a chatbot or a translating tool or a question answer tool. It's just the next word coming out. So this is kind of amazing. And a lot of people were fascinated by this, the fact that this simple model of language based around this transformer model was able to do these amazing tasks. But there were some challenges and limitations, particularly in terms of hallucinations, where the model produces an output that actually is not corresponding with reality. It doesn't match the user's intent. So I might say, what is the capital of France? And it says London. It's like, that's wrong. But remember, the model is only predicting the next word based on the input. So if it didn't have Paris in the training data, it wouldn't be able to predict Paris as the output, and it's going to predict something different. So due to the quirks of the model and some of the limitations of that architecture, we get outputs which don't correspond to what we expect it to generate. This is a big problem because it's very difficult to make it completely aligned with what we kind of know in the world. We also have problems of consent, because where does the training data for all of these models come from? It's basically just scraped off the internet or out of books and people's YouTube videos and so on. So we have consent problems, bias problems, because these models have been trained on real data, and real data is generally biased. The stereotypes and the racism and the gender bias we have in society is reflected in the data on the internet, and that gets reflected in the probabilities that are going to be generated by this algorithm, which has no real understanding of what's going on except in terms of these probabilities. And then we also have problems of deployment, maintenance, and scaling because these models are huge in practice and they require a lot of energy and time and hardware to just generate. And then we have problems of security as well with using these maliciously for different purposes. So we have these challenges and limitations. And one of the classic problems is the hallucination that I've just talked about. And I show this in every talk I do about AntConc and AI. If you ask some of these simple models who developed the AntConc software tool, we get answers like, it was developed by Future Growth Software, David Ingram, Ann Taylor, David Robinson, Mark Davis of BYU fame, University of Liverpool, Professor John Sinclair, and so on. Really crazy answers, but they're not so crazy if you think the model obviously knows something about AntConc being a corpus tool, and it also knows that Mark Davis and John Sinclair are related to corpus linguistics. So it's more probable that John Sinclair created AntConc than I did, because he's more famous and he has more publications and he's in the literature way more than I am. So if you say who created a software tool, oh, probably Sinclair. So you get the idea of why it makes these mistakes, but it is a big problem. Okay, so now we've got to this point. Oh, I've got to be careful with my time. Ooh, I haven't even got to my software yet. So is Gen AI the new corpus linguistics? And this is a bit, I want to talk about this for about 5 minutes. So if you just listen to what I just said, you probably think, no way, of course it's not. It's got nothing to do with corpus linguistics. It's just next word prediction with this algorithm, which is basically linear regression on steroids. Well, a couple of weeks ago, you may have heard Lisa Chung and Peter Crosswaite talking about corpus linguistics and Gen AI. And at that point, Peter said something interesting. He said, AI is corpus linguistics on steroids. And this got me really thinking, is this really what LLMs are? Are they like, is that what corpus linguistics is? Isn't it AI corpus linguistics? What is the connection between these models and corpus linguistics? And for us to truly understand where these are in our field, I think it's important to reflect on this point. So what do I think about this? Well, let's first remind ourselves that corpus linguistics is a methodology. It's a methodology to create corpora. So we have methods to create corpora, methods to analyze corpora, and methods to interpret corpora. So for example, we might make a quick concordance line, or we might generate some collocates. And then we look at the results, and then we think about the connections. So it's a set of methods. Now, AI models don't create corpora, right? There's no methods inside of AI for creating corpora, not in these models, certainly. These AI models don't develop new stats. They're just this next word prediction. They don't analyze or interpret data either. They just generate the next word. So there's none of the corpus methods inside the model itself. It's just a representation of language, which is designed to predict the next word. So I would say that AI models, large language models, are the result of corpus methods. They're not a replacement for corpus methods. So a large language model is a model of language. That's the best way to think about it. It's got this weird aspect that it is designed to predict the next word. So we can apply that model to predict next words, but it is just a model of language. And we can think of other models of language like pattern grammar. Susan Huntston's pattern grammar is a model of language or a model of grammar. Lexical priming, Hoey's model of priming, that's a model of language based on usage data. So an LLM is like pattern grammar, it's like lexical priming. So we would never say lexical priming is corpus linguistics. They're just completely different things. Corpus linguistics is a method and lexical priming is a model of language. But there's a slight problem here because we also have something called an AI tool. Like ChatGPT is a tool built around a language model, GPT-4 or 5. And these AI tools can assist our corpus methods and they can expand our corpus methods. This ability to do next word prediction and these magical properties of information retrieval, text generation, translation, chatbots, coding, and so on, we can use that ability to expand our corpus methods. So for example, if we want to write a new concordancer as a tool, we can use LLMs or use AI tools to write the code for our new concordancer. So we're using the AI tool to help us expand our methods. It's not the method, though. The AI tool is not the method. It's a tool. An AI tool helps us with our methods. And of course, these tools are currently unreliable because they hallucinate. They have these weird properties of hallucination and so on, and bias and so on. So we still need the humans in the loop when we use these tools. So in this sense, they're not that different from any other Corpus tool. Corpus tools are also sometimes unreliable and they need humans in the loop as well. So that's where I really see this. So LLM tools, ChatGPT, Gemini, and so on like that as a tool, excel in qualitative tasks. We can ask them to give you context-dependent, nuanced, subjective, created answers to questions, but they're less reliable at quantitative tasks when we ask them to do things like counting, measuring, obtaining objective facts. If we ask an LLM through a tool like who created Ankong, we can get a weird answer like it was Mark Davis. But it's good at doing subjective, creative tasks as well. So that's LLMs. And then corpus tools, like Ankong, excel at quantitative tasks. Like we use Ankong to do frequency counting, quick concordance generation, colloquial analysis, and so on. So corpus tools are great at quantitative tasks, but then they rely on humans for qualitative interpretation. Yeah. So if we want to kind of look at that list of frequencies and get a picture of like what words are important in English, which is a subjective question, the list of frequencies don't tell us what's important, but we can interpret that data and then decide the important words from there. So the question I have then is, I mean, the answer is fairly obvious, I think. Can we integrate AI tools like ChatGPT, like Gemini, with traditional corpus tools in our research, teaching, and learning? It's kind of like, of course, yes, because they're just a tool. We just have to be careful how we use the tools. If we blindly use them without any understanding of the underlying engine, we're in danger because we can lead to, it could generate hallucinations, it can get the wrong answers, it can count incorrectly. And if you use corpus tools without understanding anything behind them, what effect sizes are, what log likelihood ratios are, we can have the same issues of using these tools badly and producing results that have no meaning. So it's kind of similar. I think we can kind of use these tools together to maybe overcome the weaknesses of both. Both have weaknesses, and the alignment together produces an interesting symbiosis. Okay, so let's get to, we've got 20 minutes or so to go into the perhaps the most important part, but I actually think the first half of this talk was actually the most important part. So once we understand that the integration of corpus tools with AI is really just an integration of two different types of tool, an integration of two different types of tool to help us with our corpus methods, which are separate. Counting frequencies, interpreting data, making corpora, programming, developing stats. That's the methods of corpus linguistics. These tools can help us achieve those goals. So what I've created is a Corpus AI experimentation platform so that we can kind of play with these two different realms, these two different tool types, and see how they work together. So the idea here is that we have AI tools, like we have at the top here, OpenAI and Meta and Google. We have all these different tools. I'm going to say the word tools now, not models, because they're all powered by a language model, but the tools are what we kind of think about here. So we've got these AI tools like chatbots and image processing tools and translation tools and so on. And we have corpus tools like concordances and collocation tools and frequency tools. And we put them together. Okay, so I want to talk a little bit about this now. So just a moment. Okay. So the first part of this equation is, of course, the corpus part of it. Now, I've integrated this tool, this AI component into Ankong, which is a very standard corpus analysis toolkit, a traditional corpus analysis toolkit. If you don't know what Ankong is, it's basically a free, multi-platform, multilingual corpus analysis toolkit, free to use on any platform, and you can download it today. I've actually just released a new version just today so that you can try out everything I'm talking about in this talk. You can go to my website now and just type Ankong in a search engine, you'll find it. Okay, so we have this platform for doing traditional corpus linguistics called Ankonk, and I've integrated that with the AI tools. So the AI tool component, I basically put under the umbrella term of chat AI. So kind of a branding that I'm using. So the chat AI is the integration of AI with these traditional corpus tools. Okay, so let's think about chat AI then. What is this? So we have many different types of language model tools, many different, I'm going to say the word tools, but we could also think of it in models to some degree. Okay, so we have cloud-based AI tools. These are like ChatGPT, Grok, Claude, Microsoft Copilot, and so on. These are proprietary tools. They're public. Anybody can download them, but they are commercial. They cost money. They are very fast. So it's like a tool, right? When I'm talking about fast, I'm thinking tool use. They're fast, they're good performance, they cost money, and they're reliable, generally speaking. They're pretty reliable. They don't hallucinate so much. But we also have a different set of tools called local AI tools. These are open source tools, open weight tools, private tools that you can run on your own computer without any cloud services at all. They're generally free to use, but they have worse performance than these cloud-based AI tools, and they're less reliable, and they hallucinate more. Now, you may not have heard of these. Some of you, I hope some of you have, but Hugging Face is basically a library of all these local AIs. Little, small, specialized AI tools, big ones, but they're all generally open source or open weight. LM Studio is an interface to get access to all these different models. And there's like over 2 million of them right now, over 2 million. Llama is another interface to these model tools. And we have Llama File, which is another way to get access to these tools. So we have the tools in this library called Hugging Face. And then we have these other tools that give you access to them, allow you to download the tool and run it locally. Okay, so Ankonk is basically this chat AI implementation in Ankonk gives you access to both of these. Okay, now, before I talk about Ankonk, why do we even need these, especially these local AI models? So coming back to these problems in AI, hallucinations and consent and bias and so on, we can address some of these problems through these local private portable AI tools. Let me just explain why. So let's start with security and deployment. These models are completely open, generally, open weight or open access. They run on your own computer. They never leave your computer. Any data they process stays with you, like a normal application. So there's no leaking of private information. They don't help with phishing scams or data collection at all. They're just like a standalone box in your own computer that never leaves. So very secure. They also allow you to think about deployment and maintenance and scaling because you can choose the model that fits in your own computer. You don't need massive computers. You can run these on a desktop or a notebook computer. They're fine. You can also select one of millions of these models which don't promote stereotypes, that don't have positions of racism, that don't have gender bias. People make these models deliberately with good ethics or with good balance, with no stereotypes and so on. They're all like specialized for particular purposes. Some of these models completely address the consent issue and they only use training data that is copyright approved. Some of these models have no plagiarized data at all, no private data at all, anonymized and so on. So they address a lot of these issues, but they have a problem with hallucination. They hallucinate like crazy, as I'll show you in a moment, because they don't have the performance that these bigger models have. So they do address some of these issues. So it is something interesting to think about and experiment with, which is what the chat AI component of Ankonk is doing. So Ankonk's chat AI tool gives you access to all of these. So you can see on the left here, we have OpenAI models. So it gives you access to all the OpenAI models. It also gives you access to an LLM Studio bridge to over 2 million local models that you can download and run locally. And I've also got this Llama file component, which basically gives you direct access to a small set of curated local models that I feel are useful. So you don't have to go and find one of millions. You can just go to this small set of local models that will run nicely on your computer and try it out. And then if you think, oh, okay, that's interesting, now let's go to some other models and try those out. You can do that as well. So we have OpenAI models. All Hugging Face local models are accessible, like DeepSeek R1 is on, if you've heard of that. And then you also have this curated set of models. And one of those is, say, Llama 3.2, which is a very, very commonly used, popular local model. So Chat AI gives you access to those. And then we also have this integration with traditional corpus tools. So we have a bridge from standard corpus tools to Chat AI. So for example, you could run a concordance analysis with a traditional quick concordancer and then send the results to the Chat AI integration to summarize the results or give some interpretation of the results or simplify the results maybe for classroom use and things like that. You might have a set of collocates, and then you can ask the AI tool to give you some insight into why these are common collocates for a particular noun or verb and so on. Now, some traditional corpus linguists might say, oh, but that's what the human's supposed to be doing, this interpretation. But I think that view is narrow. Certainly, corpus linguists need to be doing this interpretation and insight generation and so on. But in certain applications, like in data-driven learning, for example, or classroom practice, maybe we don't want the students to always be like looking at thousands of quick concordance lines and trying to find the patterns. Why not just show them the common patterns in this authentic data and let them learn from that? It's a kind of different view from like looking at a textbook, because this is the direct, interesting, valuable data. We get these good patterns generated through the concordancer, and then we get the summary of the patterns through the AI tool. That's kind of the idea. We also have a bridge from the AI tool back into normal corpus tools. And the most common application of that would be, for example, to generate a query. If you're trying to find words in your quick concordancer, but you don't know what words to search for, the AI tool can give you some hints for what that might be. Maybe you want to do a regex search, a regular expression search, but you don't know regular expressions. You could have the AI write the regular expression for you, and then you run your traditional search with that. That's the idea of this. So just to summarize, I've got to be careful with time here. Oh, I've got it as I've been speaking for 41 minutes, but it looks like we're almost at 49 minutes on the clock. Oh, I've got to get to my demo in a quick. So anyway, this is a quick summary of the cloud-based AI. You do have to pay for that. You have to pay OpenAI for every call. But all these other implementations, like the bridge to LM Studio and the direct interaction, they're all free. And they just run like a normal corpus almost. As I say, you've probably all seen the corpus manager of Anconc, where you have a list of corpora and you click it and just use it. We have now the same thing with this curated list of AI models. So that in Anconc, there's a list of AI models that you might want to use, and you just click and use them, and that's it. Okay, so let's do a quick demo of this and then leave some time for questions. Okay, I think I'm going to only have about 5 minutes for questions, Pascal. Hope that's okay. Okay. Yeah. Okay. Good. Okay. So let's switch now to Anconc and then actually show you how this might actually work. Okay. So you can all see here Anconc. This is the latest version that you can download from the internet right now. And first of let's load in a corpus, which you've probably done many times. So we have here a new interface for the corpus selection. I won't go into this in too much detail, but let's say we want let's go to Amio6, and then we'll have the learned subcorpus as the target, and then we'll have the Amio6 full corpus as the reference. And that's it. Just pick one, pick reference, and then it's okay. So now we have the corpus selected. And of course, we can just click on these files and just see these files inside, and we can do a search like, let's say the word challenge, and we can get our results like this. We've all seen this millions of times. That's fine. But let's imagine we're trying to search for a word like hobby. Now, there's no hits for hobby. Okay, well, kind of not surprising because this is an academic subcorpus of the corpus, and hobby's not there. But maybe there's words that are similar to hobby in the corpus. Now, what would they be? What's a word that's similar to hobby? I could ask in the chat, but can you think of any? Maybe a student can't. So let's just say, give me a list of words that are similar to hobby. Now, of course, I can't search for that, right? Because that's just a question, but I can turn on my AI search, okay? And then we can ask it. But first I need to set the AI engine. So I'll go to my global settings. I'm going to use OpenAI as the model, okay? I need to put in my key for OpenAI, which I won't go into now. But I need to put in my key, and now we're ready. Oh, that's good. Okay, now we've got AI powered searching, so I can say, give me a list of words that are similar to hobby, and we get activity, pastime, interest, and pursuit as possible synonyms of the word hobby. Okay, and then we can actually see activity and interest are in the corpus. In this academic corpus. So that's kind of cool that you can just start asking questions like, give me the word but in an academic style. Okay. Okay, great. Okay, now I didn't know what the word however was, but I wanted to say but in an academic style. And now it automatically generates the word however, and now we can see all the quick results for however. So that's the idea of using this AI-powered search. So we can get these results through this natural language input. So that's one example of using this AI tool. But let's go the other way. Okay, so let's get rid of however. And now we can go to our chat AI tool. Now this is still OpenAI at the moment. And we can just use it like a normal chat engine. So we can say, okay, what is the capital of France? I've done this. I've said this a couple of times. So we can say here, and it will say, okay, the capital of France is Paris. Great. Thank you very much, which is great. But we can also say, okay, let's go back to these results. However, okay, so what about the kind of, what patterns do we find this however in? Okay, so how is however used in my quick results? Now, normally you cannot do that with ChatGPT, but here we can say, I want to use the quick results and I want to ask about the quick results and say, how is however used in my results? So hopefully the AI engine will now look at the results and summarize the patterns that we see. So we can see contrasting information, okay, including exceptions, clarifying or emphasizing a point, transitioning between ideas, and then we get this nice summary at the bottom. Now, of course, if you're a corpus linguist, you wouldn't want to be doing that. That's maybe what you should be doing yourself. But in a DDL context, maybe this is exactly what we would want a student to be playing with and trying out and so on. So that's the idea of this bridge from one to the other. All the tools can be accessed through this chat AI integration. So you can see here, we've got the file view or the cluster tool, collocates, word and keywords and so on. So we can do that kind of interaction directly. What's also cool, I've got just a minute left for my quick demo. This, of course, was using, as I just showed you, this was using OpenAI's model. But what if we're using student data that we don't want to send to OpenAI? Or what if we don't want to pay anything for OpenAI and we want to do it locally for free? As I said, we have this LM Studio bridge, which I won't go into now. It's a bit more complicated. But we also have this local AI manager that I have here. So let's just use that now. I'll just quickly show you this. Okay, so we're now using our local AI models. So we need to go to our local manager, and you can see here a list of local models curated by me that we can just use. So let's use Llama 3.2 locally, nothing to do with OpenAI, nothing to do with ChatGPT. Let's just launch this. Okay, so I've just clicked the start. it's going to boot up. Just wait a second. And then it says here, wait. Okay, the AI model has started and is ready to use. Great. Okay, so now we can go, just a second, let me get this, okay. So now we can go back to our chat AI tool. Let's just clear everything. And then say, what is the capital of France? But remember now, we're not using ChatGPT now. This is completely running locally on my computer, totally private, and we get, oh, it's a bit slow. Look at this. Okay. Now, actually, I've found that when I'm using Zoom, the local model gets much slower. I'm not sure why. When I run this without, yeah, it's just so much slower. When I'm running it without Zoom, I get the answer back almost immediately. So I think Zoom is like taking over the CPU or the GPU that on this computer and doesn't give me the answer back. So it's really frustrating when I try to do a demo on Zoom of what this looks like. But maybe I can just say, believe me, that if you run this locally, and you can try this out yourself, switching between OpenAI and local models is as simple as basically just clicking like I just did. Okay, so it's just a matter of clicking on the model and then just launching it. Oh, it's always frustrating when Zoom kind of takes over my CPU and stops me running the result like this. But try it later yourselves, and you should be able to find it just runs like OpenAI. But it's not as effective. Okay, got to finish. Okay, last, let me just switch back to my summary slide, and then we'll have a couple of seconds for summaries for Q&A. So large language models are a powerful technology that is transforming research and teaching. They do provide insights that go beyond what traditional corpus tools offer alone, but they are far from perfect, and they benefit from a grounding in this reliable, transparent traditional corpus data. And they are moving from cloud-only models to these local private models, which give you a lot of benefits, but some weaknesses as well. So integrating LLMs with traditional corpus tools, via, say, the Chat AI tool, I think it addresses some of the limitations and problems of LLMs. It also supports DDL, and it also introduces some interesting new ways to generate data, interpret corpus results, and maybe even an easy way to experiment with some of the cutting-edge cloud and local AI models. So give it a try. Try it out and see what you think. And I'll stop there. Thank you. And I should say, I have this at 51 minutes, so I'm not sure exactly where 10 minutes disappeared.
Okay,
but...
no worry. I think no worry. Okay, actually, if you use more time, I'm fine,
Yeah.
and I think the participants also fine. You know?
Yeah, I was looking at my clock and it's like, oh, I've got 10 minutes left, but now we're at 10. I think we started slightly late, but anyway, I hope that's okay, everybody.
Yeah. Okay. Good. Thank you very much. Laurence, you're always a very energetic speaker. And you influence us. You attract our attention.
Oh, thank
I think
you. I
that
hope you can follow everything.
the last part, actually, okay, so it's very interesting, the live demonstration. So I think maybe we can proceed to the QA. I think
Oh yeah, I
there
could see lots of
yeah.
I could see lots of people giving nice comments. Thank you everybody for all those. I can see your comments right now. So
Yeah,
wow,
so
there's so many.
so there are some
That
questions.
was
For
amazing.
example,
Thank
like
you.
the first
Jelena, thank you
one,
so much. That was such a
yeah.
nice comment. Claudia as well, thank you.
For example, like the first question posted at 6:39 p.m. my time, your time should be 7:39.
Yeah.
You can
Yeah, if you
select
could
some
oh,
questions to
I think
answer.
you need to. They're flying past. So if you could maybe post repeat the question, that might be good.
Okay, good, okay. So we know the large language models generate output by predicting the most probable next words, which means the how solution can occur. Even so, most users are impressed by the coherent and the logically
Yeah.
satisfying responses this system produce. Okay, blah, blah, blah. Can you explain in plain language how this is achieved?
Okay. So these models have a lot of training data, and they are able to find common patterns in the training data. What this suggests, so first, they didn't really expect that it would work that well. Even the people at OpenAI did not expect these models to be so good. Okay, so there's a bit of kind of a magic happening somewhere here. But what it would suggest first is that the model that they're using is good. So it's a good model of language. So what is the model? The model is basically words predict other words. So if you have a word like the cat, the next it's likely to appear near dog and sat and milk and lick and so on. So that's the model that we're using here. It's basically a collocation model. It's what John Sinclair was talking about back in the 70s and 80s. And the LLMs capture that model beautifully through that neural network with the non-linearity and this big amount of training data. So it seems that they've captured the nuances of English or language. So not just English, but all languages. Language, therefore, is usage-based. It's not rule-based. There are no rules in these models about verbs followed by nouns and nouns followed by verbs, past tense, none of it. There's no past tense, there's no present tense, there's no nouns, verbs, adjectives at all. There's no parts of speech, there's no metadata, there's no annotation. It's just pure usage, which means that teaching students about grammar is maybe not what humans are actually doing in their brains. They're not using grammar in the normal way that we're teaching it. So the reason why they're so coherent, I think, is because they have captured the true essence of language, which is a usage-based model. Now, why do they make mistakes? Is because a usage-based model doesn't allow you to know what the actual word should be, because that's in the reality of the world. Like Anconk was created by Laurence Anthony is just a fact in the world, but not necessarily within usage-based probabilities. So that's why they make mistakes with picking out facts and counting and so on. Does that answer the question?
Okay, cool. Thank you.
Yeah.
Because we have a lot of questions, so I think we can just select certain questions.
Yeah,
I think
please
usually
go for
we
it.
just answer, one question, from the same participant. Some participant reads more than one question, so we just answer
yeah.
one. Okay, right? Okay. All
Well,
right. So some very simple.
Yeah. Please go ahead. Go ahead.
They are very simple questions which you can answer very quickly. Okay.
Okay,
Does
go
your
ahead.
YouTube channel has a new tutorial on how to generate and input the AI key?
Oh, no. What I do have an explanation of how to do it in the help page. And actually, in the slides for this presentation, I have a bit of an explanation as well. So if you get access to the slides for this talk, you'll actually see a little bit of how to do
Okay,
that.
that's good. Because I think several participants have been asking for your PPT. Also I'm quite interested, If it'll be great, you can, willing to share the PowerPoint with us.
Of course, yes. Yes,
Okay, good.
And I should say to everybody, getting an API key for OpenAI or Gemini is pretty trivial, actually. It's basically you go to a page that if you just Google search for API key, you get a link and you just go to the page and then you basically create an account and then you just click generate key. It's surprisingly simple. But again, remember that you don't need any keys to use local models. So if you go with the Anconk's local model idea, you don't need any OpenAI key at all. You don't need any cost, no credit card information. Just access the model and just try it out.
Okay.
I think I would recommend maybe you start actually with a local model and just get a feel for how these models are working, and then maybe try these OpenAI AI keys and so on.
Oh, okay. So I have a follow-up question. So each time when we, start a new chat, we need to generate a new AI key, or just we can use the same key every time.
Oh, just a minute. The OpenAI key, if you have an API key, you just put it in global settings, and once that's it. And if you turn on in Anconk, there's a setting to remember the settings. In the global settings, there's an option to save the settings. If you save the settings, you never have to type it in again.
Oh, okay. So actually, we can pre-enter the key once. Okay,
I'm still
maybe you can
sharing
show
my
us very
screen.
quickly. Yeah, you
Okay.
can.
By the way, first, this is the local AI finally giving me the answer, the capital of France is Paris. So it did generate the answer while we were doing something else. So if you just go to the global settings, you can see here the AI setting, you type in your key, but then if you also go to restore settings, you see here it says restore previous session, yes. If you click yes, then it will always remember all the settings and it will bring them back the next time. So you only ever have to do this once.
Okay, just click on yes.
Yes, yeah.
Okay,
And then
good.
all
Okay.
settings will be saved. Yeah, that's the way they do it.
Okay, thank you. Okay, good. Okay. All right. So we don't need to pay for any subscription fee to get the key to the AI integration, right? You said that we can just
Yeah.
search Google for the key, right?
Oh, no. So where's my slide again? Just a second.
Yeah.
This is something very important to understand. I kind of went a little bit quickly at this point, but let me just summarize that slide again. So here. Okay, so this is the important difference. So we have in Ancon, there are 3 ways to access models. Cloud-based LLM. This is the state-of-the-art OpenAI and so on. This is charged, it's money related, and every time you call the model, you have to pay a small amount. To use this, you have to paste in an API key from the provider into the Ancon settings. So it's a very small amount, generally speaking, like $0.001 and things like that, but you still have to pay. But if you use this LM Studio Bridge or you directly access the models that I showed you, it's completely private and it's completely free. And there's no API keys at all. You just download the model and just run it.
Okay, all right, okay, good.
So in some sense, so it's kind of interesting that in some sense, an OpenAI approach is actually very easy because once you've got the key, you just use it and pay money. And it's very fast and easy to use, but it's completely public. These others are in some way easier to use because you just download the model and run it, but they're also in some sense more complicated in terms of infrastructure, which I'm trying to hide in the interface. So it's kind of a choice that you need to make. If you want complete privacy, the only option is to use a local AI engine. It's the only option. If you have student data or examination data and things like that, if you have data that cannot go outside your computer, then you have to use the local model, but you have access to these. And if you're not worried about privacy and you just want fast, high performance, then you can just pay for one of these open models. Open AI models. Does that make sense, everybody?
Yeah, okay, good. Thank you.
Great.
Okay, maybe the next question, because some, participant will ask several questions. I just select one, okay, to be fair. All right.
Oh, I've just seen Tianshu's question at the bottom about in-context learning. Will it provide me with distinct responses based on my previous queries? Yes. So the Ancon implementation is very like the ChatGPT implementation. In fact, you actually have more options than ChatGPT. So for example, here you can see remove previous context, and here you have maintain rolling context. And if you have that, then it does remember what you were previously talking about. So it's very like OpenAI in that respect. But you also have things like temperature controls. And in the settings, you also have the ability to change things like the system prompt, if you know what that is. So the standard system prompt is you are a helpful assistant. If you change this to something like you are an unhelpful assistant, it stops answering any questions and it will start acting very strangely and annoyingly. It's kind of fascinating to play with. You could even have, instead of you're a helpful assistant, you could have you are an expert corpus linguist. And if you do that, then the responses will become more linguistically oriented and it would have a better idea of grammar structures and so on. So normally with this, you're a helpful assistant. It's designed for just being a chatbot talking about daily life. You could say you are a grammar, god, and just go from there. You only answer using simple English expressions. Like that. So you're an expert at grammar, but you're only going to speak in a very simple, easy way so that the user can, follow what you're explaining. things like that. So you can, normally with ChatGPT, you cannot make changes like that. But in this system, it's very easy to do it. I've just done it just now.
Okay,
So,
I think maybe we will maybe answer the last three questions. Okay, so okay, now there's a question. Do you have any plans to integrate AI tools to customize corpus linguistics calculations, statistics available in Ancon for particular research or use cases?
sorry, can you read that one more time?
Do you have any plans to integrate AI tools to customize corpus linguistics calculations and statistics available in Ancon?
Okay, interesting question. I haven't thought about doing that. As I said earlier, these AI models are designed to do next word prediction. They're not particularly good at like that kind of task. Now, they are good at coding. So maybe there is an option to say, you could imagine asking it to create a function or an equation to do a particular task, but you're entering a bit of a weird realm where there's not a lot of training data on that task. So I would imagine it would generate something that looks okay, but it might not work well at all. So I think that's kind of a bit of a dangerous area for using these tools. They're good at subjective, qualitative, creative tasks. When you start wanting just very specific pieces of information, particular things, they start making mistakes. Even with coding, they're very good at coding, but they still make mistakes with coding. And you need a kind of way to iteratively work with these tools to get the code to run properly. So I think it's a bit dangerous doing that right now. I don't have immediate plans to do that.
Okay, thank you. Okay, so next question. Do you have any recommendations for navigating and selecting from the millions of available models? I mean,
Very good
I think,
question.
yeah, I think those are local models, right? I think,
Yes,
right?
very good
Yeah.
question. Okay, so again, coming back to the slides for a moment. There are over 2 million of these local models now on Hugging Face, and you can access them all through this LM Studio bridge. What's nice about the LM Studio bridge, this LM Studio is a separate application from Ancon. It's completely independent of Ancon, but it allows you to actually find popular models. So if you install LM Studio into your computer, you can actually start seeing which are the models that are trending. And you can do just a regular search, like I want to find a model that does this or that, and it kind of starts pointing you in the right direction. So I would say, it's that would be the tool I would start using to find a good model. Once you've found a good model through LM Studio, then you basically just download it into LM Studio, you launch it in LM Studio, and then you go back to Ancon and just say, in the settings here, you just say, I want to use, where's my AI setting? I want to use the LM Studio model, and that's it. And that's it. Done. So now it's just bridged across to LM Studio, and anything that's happening in LM Studio, Ancon is seeing it. So you download the model in LM Studio after finding a good model in LM Studio and then using that. To be honest, though, the other option is kind of do regular Google searching, like what is a good AI model for this purpose? And if you do that, you'll get a name of a model, and then you can, again, go to LM Studio and find it.
Okay, good. Okay,
And just one more thing about LM Studio, which is really, really good, is it also knows your hardware, and it will only suggest models that will fit on your computer. So it won't give you just a list of every model that's available in the world, because many won't run on the hardware that you have. So LM Studio looks at your hardware and says, oh, you only have this much RAM or this much space. So it won't give you an option to download the models that won't run, which is nice. So it means it filters a lot of the results.
Okay, thank you. The very last question.
Okay.
Okay. Well, I don't know if this is a good place to ask, since this is a more general AI plus corpus question, but what if our sample starts getting more and more AI based? It's the last question, very last question.
Great. Yeah, great question. This is I think this question about authenticity is a very interesting debate. So traditionally, you'll hear other speakers in other conferences say, corpus linguistics is all about authentic data. If it's not authentic, it's not corpus linguistics. But the reality is we've been moving away from authentic language in corpus linguistics for many years. If you look at, for example, Sketch Engine's popular N1010 model, it's a model of internet language. Now, some of that language is authentic, some of it's just movie scripts, some of it might be TV reports, some of it might be completely artificial. So traditionally, back in the 60s and 70s, yes, language was authentic. People went around and recorded real people speaking and so on. But over the years, as we've been trying to get bigger and bigger data sets, the authenticity definition has become much, much weaker. So we have a lot of data now which is not authentic anyway. So that would be the first response, is that we are already using inauthentic data in corpus linguistics. We're just not aware of it so much. Now, with the new data, we're getting more and more and more AI-generated data. How does that affect everything? From a linguistics perspective, I think that just raises new interesting questions for us. So one question would be, is AI-generated data language different from human language? Is it? I don't know. Maybe it is. Maybe it is. Maybe it isn't. And that would be a question that a linguist would be interested in, and an investigation of that would be very good. So when you build your corpus, then you have to think, okay, I want to build a corpus of AI-generated data and normal human-generated data. Getting the human-generated data is going to become increasingly difficult, and maybe you need to do it small scale. You need to go out and you need to collect your students' writing, making sure that they didn't use AI when they created their essays and so on. So I think it's an interesting question, and my feeling is that we've been going this direction for a while.
Okay, thank you very much. Okay, so I think let's just thank Laurence for his excellent seminar.
Wow,
thank you.
lots of well, thank you everyone. I'm reading all the comments as they're flying past here. That's great. If anybody has a question that I didn't address, please feel free to email me. I always put my email address on the screen here, anthony@waseda.jp. Just send me an email, say I saw your seminar, I have a question, just send it me and I'll be very happy to answer it.
But you will share your PowerPoint with us, right?
Yeah, I will as well. But you can
okay, maybe send to
use
Pascual. Send to Pascual.
Okay, I will. Okay. Yeah. But everybody just take a note now of the email address, anthony@waseda.jp. Send a message and I'll be very happy to answer it. And yeah.
Well, Laurence, thank you so much. You've been fab as usual. Thank you, Angel, and also thanks everyone that showed up today. Amazing number of people for your talk, Laurence. So that talks volumes about
300 people. Wow.
No, it was 400 at some point.
More. Wow.
Right.
So can I just say one last final thing then? So coming back to that, the very last thing I want to say, this symbiosis of generative AI and corpus linguistics, I don't think it's this, but it can be this if we don't understand what's happening. So think about it, reflect on what AI is, try to understand as much as you can, and hopefully we get to something like this. Thank you.
Thank you. Thank you very much.
Okay, guys, see you soon. Remember, we have another talk on Thursday, okay? Angel, Pilar, Carlos, everyone.
Yeah, thank you. Thank you very much. Okay,
thank you,
Laurence. Okay, so enjoy in the evening.
Bye, everybody.
Bye.
Yeah. Bye. It's time to go to bed.
Yeah, okay.
Bye-bye.
All right, so see you. So see some of you next